Welcome to our video demonstration of QUICKSURFACE. In this video we would like to go through and show you how you can start with a scan data like this one. Then you quickly reconstruct the object and produce a valid solid model that can be exported as a step or IGS file format and being processed in the other packages. Before I begin, let me just show you what the real part looks like. Our partner 3D Wonder found this in a garage, and just for the purposes of training he scanned and asked us to exercise and provide a good workflow of how we can reconstruct this. You can see this is quite dirty old part, and this is how it looks like. And this is originally from the catalog. The reason I'm showing you this so you can better understand what the actual shape needs to be. When I start reverse engineering, I always just ask myself what are the primary surfaces that need to be accurately reconstructed and what are that are not so important. If you look at the screen, this is where this part will be mounted and connect to the other parts in the assemblies. This is really perfectly flat here, and everything else is casting. Probably when it has been manufacturing, they have created this part roughly, and then with the machining tools they just cut off materials here. So that's why before you begin you always need to analyze what your goal is. Of course you need to be extremely accurate on this type of surfaces, and probably everything else doesn't need to be that accurate because it's not so important. It doesn't mean it will not be, but probably the accuracy you can allow to be 0.1 millimeter or even 0.2 millimeters from the surface. So let's begin. I will just start from the new empty project and will bring my raw STL data. When you import, because STL file is a unit list, it always asks you what is the unit you scanned with. Normally it's in millimeters and you can bring it on the screen. So here is the part which has been scanned, and as I told you, from the pictures I analyzed which are my primary surfaces, where I will reconstruct using the sections and sketches, revolved and extruded surfaces, but everything else I will just use it with our automatic surfacing. The second very important point when you begin reverse engineering is to position your part in space. What this means is how it is actually oriented in respect to the world coordinate axis. As you can see here, I can just see from the top, I can see from the front, and if you look at the object, it's not actually aligned. How can I justify this? Is by showing the coordinate system. You see that my x-axis is somewhere. I want this axis to be probably in the z direction. So my goal as the next step would be to align this object. Again, to align, you need to think what surfaces you need to define to be able to align this object. Obviously, this is really important area here, and this needs to be, for example, be on OXY plane. I need the axis, the z-axis, to go through this cylinder, probably here, and the third one, it will start rotate. I will use just this plane here to orient this and this to be kind of in the direction of the x-axis. But how can I do this? For this purpose I need primitives, and this is where QUICKSURFACE will help me with the tool which is called extract primitives. I'll just select it from the main toolbar. With the selection tools I can pick the regions that actually will define my primitives, and I'm going to use the magic wand. Can click and it automatically will select all the triangles which are neighbor to the initial one based on the curvature or the dihedral angle that actually is defined between two neighbor triangles. As you can see, this is my important plane, and I can just tell the software to create this plane. It's always important to check your quality. I can just click on analyze so I can see how good my plane is, and in this case I'm working with the 50 microns. This is quite good. There is some noise, but it's acceptable for my purposes. I will just create my plane and we'll carry on. In this case, as I said, I need this axis here, so I'll pick this cylinder and we'll create it as a best fit cylinder. You can instantly see the deviation, and this is really good from what I see. We'll create this. And the last feature that I need is this plane. As you can see, because it can be roughly scanned, I don't get the whole region properly selected because of the noise. But it's okay, I can just pick on a few places. This is good enough for me to define my plane, and I can define best fit plane here. So now I have these three primitives. I'll create this one. They will help me actually to reposition my part in space before I begin my reverse engineering. How we can do this is with the tool which is called Align. We have different methods for aligning, which you can learn from tutorials, but in our case we need to create a coordinate system here. So how this works, you need to pick three features, and I'll tell the software to pick the first one. I visually can see where my OX plane will be. It will be always lying onto this plane. Then, as a secondary feature, I will pick the cylinder. This means that the Z-axis will go through the center of the cylinder. And the third one will be this plane. And the software just will decide which direction it will be. It suggests that this is the Y direction, but I would like that this is actually on the other plane, which is OXZ plane. So this will define where my X-axis will be. As you can see on the screen, this will be in such a way so this plane will be parallel to the X-axis. When I'm happy, I can just press apply. So what technically happened, the software repositioned the object in space in the way that we defined. How we can check this? I'll just place it in the standard views, and you can see that my origin is exactly in the center of this rotational part. This plane is parallel to the X-axis, and my OX plane lies exactly onto my initial plane. Once I have aligned this correctly, I'm ready to begin my reverse engineering. At this moment, I no longer need my primitives. So technically I can just select, hide them, or even delete them because I'm not going to use them for now. Now I can start to reconstruct my primitives here, but at the moment, from my point of view, my better strategy will be just to separate these areas that I will reconstruct with sketches and just leave everything else that can be quickly retopologized without user interaction. I will just save this for now to have it as a working copy. And what I'm going to do now, we'll keep my original mesh by duplicating and create another entity. My original mesh I will need later for creating the sketches, but I'm going to work on this copy. What I need to do now is to get rid of these prismatic areas, and I will start from the top. We'll construct a normal plane. If you remember, this is my XY plane. Let's turn off the coordinate system so I can better understand. I analyze that this is the plane here, and this is my free-form surface that will touch and will meet this prismatic shape. So for the purposes of the quick alignment, I can just get rid of the fillet here. I will create my plane here and press OK. The next step would be, I will just select my mesh and we'll go and edit. We will use the feature which is called intersect with other primitives, which is available into the additional tools. And it has pre-selected that the plane will be my splitting tool. And I'm going to use it as a cutting tool on my mesh. I will just press preview. The software automatically splits the mesh using this plane into two different pieces. I can press OK. And now you can see that it says that we have 55 individual meshes. Go to edit. What I need to do is just get rid of this one. I will just delete it because I don't need it. and I can just click on the pieces that I don't need. Unfortunately, sometimes some of them may be a little small and tiny and you cannot see them, so the best approach would be you just pick your main body and then you click on this icon, so it removes everything else and leaves this as a mesh only. Let's press OK. Now I can see the areas which are problematic, and I can probably need to just repair a little bit here by edit and closing this area here, because automatic surfacing needs a really nice good boundaries. So you can see that I opened this hole here. I will carry on and we'll place in top view. This is where the thread is. If you think about, we don't need to remodel the whole thread because it will be machined with a different tool. What I need actually is just to define this as a cylindrical hole, so the machine can define the drills, but we don't need to actually remodel the whole thread. Also, because I want this area to be created with the freeform, I don't really need it. So for this purpose, I'm going to use our edit tool. We'll select this, make sure that select through is on, and we'll delete this area. Then I'm going to hole mode and we'll actually close these areas because I want to have this as a automatic surface to be filled. I can expand this to get a better surface here. What I did, I double click to get this hole closed. In such a way I can use these tools to defeature my shape. Let's go back and select this circle, edit, double click on the hole to get filled, and on the other side as well. I can always just go back and check how many individual meshes I have. I can just select this one and leave it on the screen to get everything removed. This is another hole that needs to be filled, so you need to do some pre-processing until you get a good surface for automatic surfacing. I can just always just click here on this button to expand and make the hole bigger. The reason for this is to avoid these curly edges, and press this. With the tracking tool you can go through the holes. You can see this one will pay another attention on this one. I need to actually close these as well. For this reason I go back, and what I'm going to do is we'll use the selection tool and we'll isolate this on the screen just to remove everything else temporarily. Here I'm going to use my circle selection, delete, and let's close the hole. I know this process may look a little bit tedious for you, but this is if you want to achieve a good result. I can just track again and see what happens with the holes. Let me just show everything that I've hidden. Here I also need to defeature. I will just put this now in a faster play, not because I'm worried, but just to save you all this tedious information that you see on the screen. Again, if you look at the object, these are markers. So what you can do to get a much better result is that you need to defeature some of them. In this case, I don't need to have this select through. I can just select this one, delete, go probably pick this one and delete. Go into the holes and fill them. Sometimes you may get some issues like this one. What you can do is just measure this size roughly, it's around 2 square millimeters, and then you can just repair all of this size. The software will automatically remove them. I can continue and close my holes. You can learn about how to close holes from our dedicated tutorials, so I'm not going to pay too big attention on this one. So in this way I have just defeatured until this level. What we can do also is to recreate the area here again to be able to do this for automatic surfacing. How can I do this? I will just go and we'll extract primitives. We'll pick this, and because it's a bit noisy I need to play with the slider to get the axis of this cylinder. We'll define the cylinder and we'll create it as a reference in this case. What I mean with the reference is that I need to create a body which will be this profile. I will select my cylinder and we'll create a sketch. What I mean with this is a rotational sketch here, and I will just use this profile to define my conceptual shape and create. What I'm going to do now, I'll hide the cylinder and we'll reconstruct my sketch. I will just brush to create my line here. Definitely this probably needs to be a horizontal line, and I will need to extract this line also. I can just brush to get them intersected and brush again to get the fillet. For now I'm not going to add the fillet here, and we'll make this much bigger. This also will come out. The reason for doing this, I'm going to make a revolved surface that will cut through this shape. In fact, in this moment of reconstruction, I need to cut this area from the mesh for the purposes of automatic surfacing. So technically what I'm going to do is just put this inside so we can remove enough material from our mesh, and then I will just select and create this as a revolved surface. So you can see what is the shape here. It's good enough for me. The idea is that I get rid of the fillet here, and again, if you remember, I'm going to edit my mesh and we'll use the trim tool, split mesh with the other primitives, and press preview. You can see that we're about to remove this surface here because this is something that I don't want. I'll go to edit, click the big one and just leave this one on the screen. For the purposes of automatic surfaces, I need to analyze the holes and go and edit using the control key. We'll just close these semi-holes so we can get a nice and smooth boundary here. Click, and this looks okay to me. To move on for the automatic surfacing, I need to actually close this hole here in a better way. Edit, and we'll just close it. I can track the number of holes that I have, so we don't get surprisingly some smaller holes. No, but everything looks good to me. So you can continue, and with the same approach you can build this shape as a flat, and also here you can define this and cut from the mesh. And for now I'm just going to save this, and what I'm going to do here, I will use automatic surfacing with just a single button. In this case I see that it's a higher feature details I want to capture, and I want more number of small quads that will be created. I press OK, and as you can see, this is in real time. Now it will just convert everything into an automatic surfacing. Why I'm using this? Because this is not so important as a shape, it's more important the mechanical area here, and you can see what we have generated. You can just increase this and decrease. For example, you can play with the medium, and I will show you in principle what the next step should be. I've finalized, and this is my automatic surfacing. What I'm going to do now, I'll double click to edit. We'll put it in the standard view so you can understand. What I'm going to do now, I will just double click and we'll extend this a little bit. The reason for this is I can probably even scale so I can get a better shape. I can just place this into the world coordinate system. And also, as you see, we need to probably extend also this part of the shape so you can get out of the, we have a shape here. I can just move it out. You can adjust and tweak your shape, but if you remember, I created this plane here. The main idea is that my surface, it goes actually into this body. It's not so important how it looks like outside, but it's important where they actually connect, and you may need to spend some time to improve this. So I will close this for now, and I will go to my original scan data where I want to reconstruct the top high quality surfaces. The way I can do this is just by selecting a 2D sketch, and we'll use something which is called for revolved surface. There are a lot of tools here that you can allow you to make stacked sections, so you can get not only one but multiple stacked sections here, so you can get a much better accuracy. But for demonstration, I'll just pick a single one so you can understand the principles. Now, what I need to do is to reconstruct this profile. I will just start using my features. Let's hide out surface for now. I can just hold Ctrl-Shift to fit a line, and I can just quickly start reconstructing my profile. Again, you need to think about what is the design intent. If this is a chamfer or this is actually a problem of the surface, I can just select this and make horizontal on purpose. If I want to join two lines, I just hold Control key and brush over the corners. If I brush again on such a corner, it automatically will create a fillet. And in this way, I can just quickly reconstruct my profile. For the purpose of demonstration, I'm not spending too much time on making this perfectly accurate, but you can add dimensions here. You can add your own control. I just use this control brush here, probably is a fillet. Let me just try to get a connection here. It's your decision how you can approach the thread here. I'll just use it as a straight line. I will just create this so they can intersect. And you can see how quickly I can just reconstruct my shape. Here you need to pay attention. Yeah, this horizontal line, so it can create a nice and flat surface here. Continue to intersecting just with a single brush. Brush again to get a fillet. If you want more details about this process, you better refer to our tutorials where we spend more time explaining every individual feature. So what I'm doing here is just making this bigger. The reason for this is if you look at the object, it simply gets extended out of my freeform shape. So I'm quite happy with this. I'm not going to make a solid with this revolve, but just a revolved surface. I can press OK. The next step would be I can just select my sketch, right click on it and say I want to make a revolve. You can see that this is my revolved surface, and what I need to do now is just use our trim command. The way it works, you just select the two features. You can do this on the screen or in the object tree, and then you can click on the trim button. As you can see, they're colored in two. What our goal is now to create a start towards making a solid or single surface in this case. By clicking on the part, you can just remove what is not needed, and you can see the indicator that it says that now it's a single surface. When you're happy with these, they're properly connected, you can press OK. And this way, you can just reconstruct your shape. Now we just wait the object to finish. The same way you can continue and reconstruct the other holes here. For example, I can just bring my original shape here and let's explore. This is my original part. I'm going to define my primitive here, which is the plane. We'll create my reference plane, check the accuracy, it's pretty good, and we'll create it. Here I will create a sketch, and in this case I can probably use the outline to get this circle, cylindrical, and we'll create. This will define my shape. I can just go and use my brush tool to fit a circle here to get the axis of my cylinder, and we'll generate this as an extrusion. The reason I'm doing this is just to get cut through my current shape here, for example. How can I do this? I can probably use again my trim tool, select this one, then with the control select the other one, and this is my trim command. I'll just pick this so I don't need them, and this is my shape. When I'm ready, I can just press OK. So this is in general, in principle, how you can do this. I'm just going to load our final results as you saw on our short video, and so you can see the last steps, how we can reconstruct it. This tutorial took a little bit longer because I tried to explain most of the principles. If you want to learn more, just contact us for an individual demonstration, and we will be really happy to give you online training and support and show you the step-by-step if you don't understand anything. But as you can see, with our tools, the people can easily just reconstruct really complex shapes like the one on the screen, which comprises of prismatic shapes that are needed for mounting and everything else that it's casting. I hope this video was useful. I appreciate your time and thank you for watching.